Okay, so I apply the other part to it with tape. This is a temporary setting. So as you see, that would fit alongside smoothly straight and for the thigh. And like I said, 13 coils will have to go under here, sections of 500. So that's 500 turns per unit, and that's 13 coils here and 13 coils, copper coils here. Each coil must be spun into 500 turns, and I'm going to overlay this with acrylic, and I'm going to make a housing and facility as far as for submersible using dielectric liquid to submersible the coils within a system separately. So each part is separated with acrylic overlay and acrylic underlay. So that will be boxed off with fluid inside the chamber. So I'm just going to cut a piece of acrylic over here to make the bottom and acrylic from the top, and that will be a bottom and top cork. And that should be about 11 millimeters or actually 3 millimeters thick gauge. And 2 pieces of acrylic, one on the top and one on the inside, which submersible the materials and compounds. There I can overlay it with other different parts. Now, the acrylic is one part, then I'm going to overlay with another piece of acrylic that is about 3 millimeters thick, 1.8 of an inch, and make circular hole depths for the permanent magnet to rotate in this area in the central. Also, permanent magnets to rotate along the side. That will synchronize the coil within the submersible, the dielectric liquid. The dielectric liquid shall enable the coil to have low temperatures. I'm also going to be using like a thermal hyperhysteresis, whereas I'm going to be using permanent magnets and electromagnets for gadolinium. Gadolinium material will be oscillating inside, so to cool through the system, where I'm going to use a cooler system with aluminum tubing around the segment. This is at the same time within the range of the permanent magnets that is supposed to go around the edge of each individual piece. So even though the piece is going to be separate from this piece, from the following piece, and a series of separate thermal hyperhysteresis refrigeration, we're using magnetic refrigeration. And that's what I'm going to be doing with each part of the segments. And there's the phase wires, the phase point wires. I have them here and here for the phasing going upward. So like I said, this is a temporary setting. I use the tape so I can mount and position each part together to see how it would fit for the subsystem, which is actually the internal engine. This is the internal engine. However, the other part of the segment, which is the frontal, where it's going to have iron and aluminum first, but then iron and copper. So aluminum, then copper, then iron. And that should enable it to move to actuating. So there, I have to hold it up because it doesn't fit all the way to a hold, so I'm just holding it over my pants. Now, to be continued, I'll be back with more and doing the kneecap, which will be another slide to slide over this unit, and a little bit proportional over the unit for the kneecap, and then I'll continue to the other part of the leg, each part singly individually. And for the biaxial ROM, using the biaxial ROM, hip biaxial ROM bracket localized here with a motor mount of the coil and permanent magnet motor mount to control the area. Now, as far as the armature, it's like a latch, but it's going to allow it to rotate in symbolics like one of the. I'll show you that later. Symbolically, so it may rotate and open and close. Now, the parodying about the servos, I can use those as motors, and as far as the armature, back and forth.
Robot aircraft vehicle suit. Wearable biomechanical AI bionic robot aircraft vehicle suit. Subject to mechanical structural transformation prospectively. Morton wearable biomechanical AI bionic. Robot aircraft vehicle suit aerial dynamics manipulator prospectively. Morton wearable biomechanical. Structural transformation prospectively into road vehicle or aircraft vehicle manipulator. Morton wearable biomechanical human movement manipulator. Wearable bionic computing manipulator. Wearable ambient intelligence manipulator. Wearable ubiquitous man cycle suit biomechanical structural manipulator. Morton wearable full body bionic armor suit. Morton mode is superior to that of the regular jetpack. Morton wearable providing manned amplification suitable wearable AI robot that suppresses difficulties and increases